You're welcome to my channel. In case this is your first time of being in my channel, please subscribe. So in today's topic, we'll be considering how to name inorganic salts. So for you to successfully name inorganic salt, there are some terms you need to be familiar with. And one of the terms here, oxygen, is always abbreviated as oxo. So whenever you see oxo, it's because of presence of oxygen. Okay, so when you see sulfur, you hear something like sulfate. When you see SO4, sulfate. Okay, then when you see carbon, it will be written as carbonate, that is CO₃. Okay, then when you see phosphorus, is written as phosphate, as in PO4. Nitrate, nitrogen is written as nitrate, which is NO3. Okay, so another thing also you need to be familiar is when you hear mono, they are talking about one. When you hear di, they are talking about two. When you hear tri, they are talking about three. Tetra, four. Penta, five. Hexa, six. Hepta, seven. Octa, eight. Nona, nine. Deca, 10. So you need to be very well familiar with these names. Alright, let's take some examples. Okay, we're given some salt to calculate. Now before I go further, you need to know first of all how to calculate charge in an element. Let's take an example. We have sodium with our atomic number 11. How do we know the charge it has? We can use our shell to know. We can use our shell. You know that the inner one always take 2, then others will take 8. This is 10. Is remaining 1, and this is 1. So now at this point now we can say that it gives. Okay, so whenever in a shell an element has 1, 2 or 3 at the outer shell, just know that it's giving, and when it giving or when it gives, it changes to plus 1. So that's why sodium always have plus 1. Is that okay? All right, now let's calculate this. Now the first example, okay, now for you to name a salt, you must find the charge of the central element. The central element here is carbon. Okay, now we have to add all the charges in this compound for us to give it a proper name. The first, this one, calcium, has a charge of +2. Of course, we don't need to write plus. Then we add, then this is X because we are looking for the central carbon, the central element, X, and then plus. Oxygen has a charge of -2, and we have 3 oxygens there, times 3 equal to 0. Okay, so a neutral compound is always equated to 0 unless a charged compound. Now we can now start. 2 minus 2 times 3 will give us 6. So let's just write it this way: -6 equal to 0. So now let's collect like terms. 2 minus 6 plus x equal to 0. and 2 minus 6 will have minus 4 plus x equal to 0. So now we want to equal to 0. We want to send this 4 to this other side. It will change to plus. Okay, so our x is now equal to plus 4. Then how can we name this? Now let's take this part to be the front side. Let's take this side to be our back side. Okay, so in naming inorganic salts, we start from the front and then we move to the back. We start from the front and we move to the back. Now let's start it now. The first one at the front is calcium, so write calcium. Then we now move to the back. Remember that I told you that 3 is tri, okay, and then oxygen is oxo. So calcium tri, because there are 3 oxygens, trioxo. Then we also have carbon, which is written as carbonate, trioxocarbonate, carbonate 4 in Roman numeral, please, 4, which is IV 4. Okay, so we started from the front, calcium, we went to the back, trioxo, because there are 3 oxygens here, trioxocarbonate 4, because this is our central carbon, what it gave us. So in some, this is WAEC standard. In some textbook it will just be written as calcium carbonate, which is also correct. It depends on what they are asking you to look for. Okay, let's calculate the second one. Okay, the second one, they added aluminium for us. Alright, so as usual we are going to be looking for the central element. Look for the central element, which is nitrogen. Now aluminium, the charge of aluminium is +3, so we have 3 plus. Now this 3 that is outside the bracket, it means it's going to multiply everything that is inside the bracket. So now our unknown, we are looking for nitrogen, which is x. So 3 times x will give us 3x plus. Then oxygen, we have 3 oxygen and 3 outside, so 3 times 3, 9. So oxygen has charge of -2 times 9. Everything is equal to 0. So 3 plus 3x, 2 times 9 will give us 18 minus 18. Okay, sorry, minus 18 equal to 0. So we collect like terms. 3 minus 18 plus 3x equal to 0. So 3 minus 18 will give us minus 15 plus 3x equal to 0. So we now send our 15 to this other side to change to plus. So 3x equal to plus 15. Now for us to make x stand alone, we divide everything by the coefficient of x, which is 3. So 3 cancel 3, and then 3 divide 15. Once 3 divide 15, we are going to have 5. So 5. Therefore, our x is equal to 5 plus 5. Sorry. So how can we name this thing? Remember, inorganic salt, we start naming from the front, then we enter the back. So from the front, we have aluminium, then the back, trioxo. We have 3 oxygens. Okay, don't go and add this one that is outside. This is just in the bracket, it's not part of the chemical bonding. Trioxo nitrate, we got 5 here, nitrate 5, which is V. Okay, in some textbook, of course, it might be written as aluminum nitrate, just like that. All of them is correct. It depends on what you are working on. All right, so let's solve the last question. Okay, the C part says alright, so this our central element here is sulfur. So what is the charge of magnesium? Magnesium have +2, so we have 2 plus x plus charge of oxygen is 2, and we have 4 oxygens times 4, everything equal to 0. Now you might be asking, why didn't you add the charges of this water of crystallization here? Now one thing you need to know in this place is that this water is not chemically bonded to these compounds. It's not like chemically bonded as others. It's just a physical combination. Okay, so we don't need to add it at this point. Alright, so let's proceed. 2, this times this is 8, so collect like terms. 2 minus 8 plus x equal to 0. So 2 minus 8, we have -4. Sorry, we have -6 plus x equal to 0. So we are sending -6 to this other side, changes to minus or plus. So x is equal to plus 6. So how do we give it a name? How do we name such this thing with water crystallization? So first, the rules, we always start from the front to the back. So we now have magnesium, then we'll go to the back. Remember, now we have 4 oxygens, so it will no longer be trioxo, it will be tetra. Okay, magnesium tetra oxo. Okay, tetraoxo sulfate, because we have sulfur, it changes to sulfate. Sulfate what? 6, because that is the charge of the sulfur. Sulfate 6, which is Vi. Then we now add this water. Now this water is 7. Okay, and now you know that 7 is hepta, so 7 hepta hydrates. So have you seen I named it from the front magnesium, then I went to the back tetra, because we have 4 oxygens. Tetra sulfate, because of the presence of this sulfur, sulfate 6, the charge of the sulfur. Then it has water of crystallization. We need to give the water a name too. 6, hepta. Hepta means 7. Heptahydrate means, hydrate means water, presence of water. Heptahydrate. Have you seen it? It's very, very simple. Now let's look at how can we calculate that of acid. How can we name acid? Inorganic acid. Then the central, looking for the central element here, plus X. Okay. Then plus minus 2 times, we have 3 oxygens. Of course, it equals to 0 because it's neutral compound. It's a neutral compound. So 1, we collect like terms because of time. Minus 2 times 3 is 6. So 1 minus 6 plus X equals to 0. So 1 minus 6 is minus 5 plus X equal to 0. So we are sending minus 5 to this other side. We have X is equals to plus 5. Okay, so how can we name acid now? Remember, the first one we started from the front, our front here, to the back. But that's now we are going to name acid now. Okay, remember that most compound that has hydrogen attached to them, they are acid. Most, I didn't say all of them, most of them. That means there are exceptions. Okay, but in this case, these are inorganic acids. Now, how can we name such an acid now? We will not start from the front to the back again. No. Look at how we are going to do it. We'll start from the back, then we go to the middle. So naming it now, it will now be from the back. We have tri, okay, because of 3. Trioxo nitrate. Triosonitrate. Look at what we got here. 5. Triosonitrate 5 acid. Okay. We started from the back. Trioxo, because of oxygen, nitrate, nitrogen, 5 acid. Have you seen it? Okay. Feel free to pause the video and invite your friends to watch. You might be helping someone. Now let's look at the B part. You have H₂CO₃. So 2 hydrogen, central carbon. We're looking for central element, which is carbon. X plus minus 2 times 3. Everything is equal to 0. Alright, so 2 minus 2 times 3 is minus 6, collecting like terms, plus X equal to 0. 2 minus 6 is minus 4. Minus 4 plus X equal to 0. So sending minus 4 to this other side, it will change to plus. X is equals to plus 4. Then our naming starts from the back to the middle. Alright, so we have trioxo, carbonate 4. So let's solve the last one, the C, H₂SO₄. 2 hydrogen, our central element is sulfur, minus 2 times 4 equal to 0. Then 2 minus 2 times 4 is minus 8 plus x equal to 0. Minus 2 minus 8 is minus 6 plus x equal to 0. So sending minus 6 to this other side, we have x equal to plus 6. Okay, now our naming starts from this other side. From the, it's no longer from the first, is now from the last. Okay, now let's start. Now we have 4. What do you think? 4 will be tetraoxo sulfate sulfate 6 acid. In some cases it might be called or known as sulfuric acid. Sulfuric acid. What if you have something like this? Is a bonus. It's bonus for us. What if you have something like this? CO₂ or Ca2. How can you name that? Now we name this as carbon 4 oxide because of the charge, of course. This one has minus 2 times 2. Okay, that is carbon 4 or carbon dioxide. But this one now, it has this thing now. Now let's say carbon dioxide. But in this other side here, what do you think? Are we going to say calcium dichlorine or chloride? No, that is not possible. It will just be, we'll just name it as calcium chloride. Calcium chloride. But the question is, how come we did not include the di or tri or mono in this case here? But in this place now we included it, and you can even include the Roman numeral. It is very simple. The thing is that this very compound is, number one, the reason is because, one, this very compound is an ionic compound. It is an ionic compound. And also, calcium has a fixed charge. That means the charge of calcium is +2 and it doesn't change. It has a fixed charge. Okay, and then another thing is that this compound does not contain a polyatomic ion. For example, this is a polyatomic ion, SO₄. Okay, polyatomic ions, it doesn't have it. That is why we don't need to include the di or tri. So first, the calcium, it contains a fixed charge, and the calcium chloride is an ionic compound. Okay, now how about this one? Why do we include it in this very case here? Because first, this is not an ionic compound, this is a covalent compound. Okay, and also carbon does not contain a fixed charge, so we need to indicate the charge it has. Okay, we need to show the charge it has so that the person marking our script will know what we are talking about. So how about when we have something like this? How can we calculate the charge? How can we also calculate or name a transition element. Okay, there are some compounds that contains transition elements. How can we name them? In my next video, we'll be exploring how we can calculate such things like this, and also give a name to transition elements. For example, where we have K2 Cr2O7. Okay, now this compound contains a transition element. It's not the same way we name this other one, so there's a slight difference. How can we calculate it, and how can we calculate the charge in this place? So my next video will be exploring how to do this. It is very easy and it's very simple. Okay, so now solve this and post in the comment section. Please post in the comment section. Let's see what you got. Calculate the charge. Okay, identify the central atom, calculate the charge, and give a name to it. Just two questions. You calculate the charge and give name to it. So now you have learned how to calculate inorganic compounds, both inorganic salts and inorganic acid. Alright, so feel free to post the video and share.